Hi, everyone. Thanks for showing up for your learning. Right now, we're looking at section 1.6, where we've been given the roots of a quadratic equation, and we want to find its equation. So let's take a look. The first ones are just number ones, and the next one is I'll show you how to go through a word question like this and answer it. I don't have the other questions for this one underneath, but I remember them, so I'll talk about them when I get there. You can look in your textbooks. So let's take a look. If we know that a quadratic function has x intercepts at the points -2, 0, and 5, 0, plus it goes through the point 3, 5. Let's find its equation. First of all, we're going to call it f of x. It's some function of x. Hold on. Let's keep going. So we're going to call it f of x. And we know that there's going to be some stretch factor multiplied by x minus the first root multiplied by x minus the second root. Okay? And we're told the roots, they're there and they're there. All right? So let's put those values in. Okay, so we know that this is equal to a multiplied by x minus 2. Oh, Mr. Jennings, he's so careful with his substitutions. X minus 5. Oh, I'm so careful with my substitutions. That means I avoid errors. So then I can simplify that just a little bit. I'm going to remove the brackets within brackets. A multiplied by x plus 2 multiplied by x minus 5. One moment. Carry on. So now we have this, and all we're missing is the point A. Oh, sorry, the value A of the stretch factor. And then we need a third point in order to find it. All right, let's go with a quick Desmos visualization. Let's take a look at this situation, folks. So here I've got the family of quadratics that satisfy these conditions. They have roots at -2 and +5. And we don't know the A value. It could be anything. Could be one or two or three. I have the step set too small here. Let's go with 0.2. Okay, let's try that. Okay, so now you can see that there's quite a number of quadratics, and that one there, no, it's somewhere in between -0.2 and -0.4. Maybe it's like a third or something like that. So anyway, you see how that one misses too high and the other one misses too low. So it's somewhere between, like it might be like 0.5, -0.5. Oh yeah, it is. It's -0.5. All right, so that would be the value that, and it's the only value of A that's going to put this quadratic right through there. All right, and how can we find that? How can we find that algebraically? Because you're not going to have access to Desmos and just be able to play around. See, infinite quadratics. Only one of them goes through that point. So let's take a look at algebraically how we do it. You just substitute this point in and solve for A. So I know that the value of the function is 5. I know its output is 5 when its input is 3. So let's put that in for A multiplied by 3 plus 2 multiplied by 3 minus 5. Okay, so 5 is equal to 3 plus 2 is 5. 3 minus 5 is -2. So this is A times 5 times -2. Okay, simplify. 5 is equal to -10A. Divide both sides by -10. And then you will get -1/2 is equal to A. So then we have and then we just put that in here. Okay, just going to add it to this one. Therefore, f of x is equal to -1/2 x plus 2 multiplied by x minus 5. Delightful. Okay, let's try the next one. Next one's a little harder because it's got funky rational roots. All right, this next one has x-intercepts at -2 plus or minus √5 and contains the point -4, 5. So I'm going to write those down. -2 plus or minus square root of 5. And it contains the point -4. 5. Okay. Yeah. So let's do it. So we know that f of x, the function that we're looking for, we could have called it g of x or q of x or whatever you want, but I just default f of x, is equal to the stretch factor, which we'll solve with algebra, multiplied by x minus r times x minus s. And then we substitute in for x minus -2 plus the square root of 5 is one of the roots, multiplied by x minus -2 minus square root of 5. Notice I used all of the extra brackets, and that's going to help me avoid errors. A is equal to x negative -2 is plus 2. Negative root 5 is minus root 5. Okay. And then this one is x minus -2 is plus 2. Minus root 5 is plus root 5. Okay. And we can also, I always encourage you to do a little visualization, and you want to be able to visualize even this, okay, where you would know that it has two roots. One of them is -2 plus root 5, and so that's barely positive. Barely positive, okay, because root 5 is about 2.2. So -2 plus root 5 is about 0.2. So it's barely on the positive side. And then -2 minus root 5 is quite negative. Okay, so we know it has roots there and there. And then the point -4, 5. Well, 4 is a little bit inside that point -2 minus root 5. So that's actually the point up here. So we're expecting some a value that's negative and has a magnitude that's fairly large. Okay, because it jumps up pretty fast. It jumps up by 5, just going there about 0.2 in the x. So again, we know that a is less than 0. And that's going to be good for our error checking. All right, now let's use this point here, and we're going to substitute it in. Okay, we know that the value of the function is 5 when x is -4. So a multiplied by -4 plus 2 minus root 5 multiplied by -4 plus 2 plus root 5. All right. Now, simplify. Okay, this is going to be 5 is equal to a multiplied by -2 minus root 5 multiplied by -2 plus root 5. All right, now how do we do this multiplication? We've been asked to multiply these two numbers, and they're just numbers. -2 minus root 5 is one number. And then -2 plus root 5 is one number. We're multiplying them. When you're multiplying two things, use your FOIL rule like this. -2 times -2, -2 times positive root 5, minus root 5 times -2, and minus root 5 times positive root 5. It's the same as multiplying two binomials. So let's go for it. 5 is equal to a multiplied by -2 times -2 is 4. -2 times positive root 5 is -2 root 5. Negative root 5 times -2 is positive 2 root 5. There's two negatives in that particular small multiplication problem, so the answer is positive there. Notice that those are going to cancel out. And negative root 5 times positive root 5 is -5. Because root 5 times root 5 is 5. But we have one negative, so it's a negative. Okay, simplify. Okay, 5 is equal to a multiplied by -2 root 5 plus 2 root 5. Can you see that 0? 4 minus 5 is -1. Okay, so now let's divide both sides by -1. Oh, that's going to match our visualization. -5 is equal to a. Cool. All right, -5 is equal to a. So that tells me that my function, I'm going to use this here, okay? I'll just use a different color so you can see it real clear when I write my answer. Therefore, f of x is equal to -5 multiplied by x plus 2 minus root 5 multiplied by x plus 2 plus root 5. Okay, that's our function. And we're done. That's it. Okay, so now, how are we going to apply this to word problem type things? Like over here, where a golf ball is hit and it lands on a point the same horizontal plane 53 meters away. Mr. Jennings, I'm already lost. Well, don't be lost. Just draw a picture. Okay, you've seen like golf on TV, so you should be able to draw a picture and start by drawing, because you know when you watch golf on TV, you visualize the XY plane, right? Don't you? No, you don't. Okay, but now you're going to start to, because you're going to say, well, I'm going to have this in terms of x and y. X is horizontal distance, y is vertical distance. Golf ball. Let's say the golf ball is hit at 0, 0. Sure. And it lands on the point the same horizontal plane 53 away. So that's the point 53, 0. Notice that that's 53 away from the origin. Cool. And the path of the ball took it just over a 9-meter tall tree. So you're going to go ahead and get your forest green color. And it was 8 meters from the golfer, and it's 9 meters high. So this is over here, 8 meters away. That's 8. And then it's 9 meters high up there. Okay, so that's the top of the tree. We're going to draw the tree for style points. And we're going to label our point. That's the point 8, 9. Okay, so I've got a few points labeled 53, 0, 8, 9, and 0, 0. Why 0, 0? Because I chose that. And then this golf ball goes up past the tree and comes down there. And I've been asked to find, assume the ball is hit from the origin. Okay, done. I did that. We assume that the ball was hit from the origin. Cool. Find the quadratic function that describes the path of the ball. Great. Okay, we would also do this if we wanted to find the maximum height. And that's going to be question 7b. Okay, so let's go. Let's do it. All right, so how are we going to do that? Well, same as we've been doing. We know that the path of the ball is some kind of function, and it's equal to a multiplied by x minus r times x minus s. And then let's substitute in the roots. F of x is equal to a multiplied by x minus 0, because our first root is there at 0, 0. And our next root is there at 53. Okay, we could simplify. F of x is equal to a multiplied by x multiplied by x minus 53. Notice that x minus 0 just creates a root x. Now, we are going to use this point to solve for a, 8, 9. So we know that when the function is at x value 8, it has an output of 9. Okay, that's the point that we're looking for. So 9 is equal to a multiplied by 8 multiplied by 8 minus 53. Okay, we know a is negative because this is a quadratic that's opening downwards. And it looks fairly shallow, to be honest. So I'm expecting some a value that's between -1 and 0. Okay, so 8 minus 53 gives me -45. 9, oh, and that's going to share factors with 9. That's nice. A multiplied by 8 multiplied by -45. 8 times -45 gives you, is that what, 180? -180? Am I right? I don't think I'm right. I think it's -360. Yeah, it sure is -360. 9 equals a times -360. Or you could write -360a, divide both sides by -360. And that will give you 1 over 40, but it's negative, is equal to a. Okay, so now let's write our new equation. Therefore, f of x equals -1 over 40 multiplied by x minus 53 describes the path of the ball. and I'll prepare a brief Desmos visualization. Okay, here's our visualization. I've drawn the tree. I've drawn the path of the ball starting at the origin. I used our function, the one that we developed with algebra. Here's the point on 8 meters away, 9 meters high. That's the top of the tree. Here's the vertex. We're going to be asked to find that in just a moment. 26.5, 17.556. That looks like 5 over 9 to me. And then it holes in one there at 53 yards away or meters away or whatever. Okay, there's the flag. Cool, right? All right, isn't Desmos lovely? Now, let's see if we can find algebraically why what the height is, okay? So how would we do that? Well, we can complete the square, or we can just know where to find the vertex, okay? So if f of x is equal to negative 1 over 40 multiplied by x minus 53. We know that the roots are at 0, 0 and 53, 0. We see that over here, right? 0, 0, 53, 0. So it's here. And here are our roots. The axis of symmetry will be dead in the middle of them, 22 and a half. Oh, sorry, 26 and a half. 26 and a half. I don't know where 22 and a half came from. 26 and a half there is the axis of symmetry. I'll even show that to you. Here is the axis of symmetry. X equals 26.5. There, goes right through the vertex. It's the average of those two, 0 and 53. So let's just input that into our function. That should give us the coordinates of the vertex. One moment. So let's input this into our function. All right. So we know that the vertex happens like HK. The coordinates of the vertex are going to be at 26.5 and something. We don't know that yet, but we want to know the maximum height of the ball. Let's just input it. F at 26.5 is equal to negative 1 over 40 multiplied by 26.5 multiplied by 26.5 minus 53. 26.5 minus 53 happens to be negative 26.5. So we're going to have this is equal to negative 1 over 40 multiplied by 26.5 multiplied by negative 26.5. So we're going to have two negatives here. That means the answer is positive. That's good news because we know that the ball will be up in the air, not underground. So that should make sense. And this is going to be equal to 26.5 squared, because it's itself multiplied by itself, divided by 40. Let's put that into our calculator. 26.5 times 26.5 equals divided by 40 equals 17.55625. Okay, how accurate do we need it? I'd say 17.6 is plenty accurate. So it is approximately equal to 17.6 meters. Therefore, the ball flies 17.6 meters high. Done. So that's how you would do this type of problem. The last problem that they ask us about with this is if we had not put the contact point, the ball hit from the origin, if we had chosen a different point, would we have gotten another quadratic? And yes, absolutely. I'll show you another way we could have done it. We could have done it at minus 26.5 and plus 26.5. And then we would have been hitting the ball from here. It would have gone up to there. We put the vertex on the y-axis, and then it came down there. That's a different function that we could have also been using. We would have had to move our tree over, but ain't nobody got time to move all that tree over there. This is how I drew the tree. You can figure that out on your own. Anyway, so those are those questions. If you have any questions about these questions, absolutely send me an email. And thank you again for showing up for your learning. Bye for now, everyone.